faster than the fabric of space-time can keep up with it, and it'll just rip. And I'm terrified by this.
Elon Musk has just made a bold prediction about Betelgeuse, and it's already making headlines. For years, scientists have been captivated by the mysterious behavior of this star, with many wondering if the supernova we've all been waiting for already happened. Now, Musk has a different take. He's not only revealing when the Betelgeuse explosion could happen, but exactly how it might light up the night sky. But what does this mean for Earth?
They are among the biggest explosions of radio energy in the entire universe.
Will Betelgeuse's supernova have any real impact on our planet, as some scientists have suggested? Join us as we uncover Musk's predictions and explore the science behind Betelgeuse's impending explosion.
Supernovas are a big, giant, dramatic end to a star's life.
How Betelgeuse explosion will happen. According to Elon Musk, the explosion of Betelgeuse, a massive star nearing the end of its life, could light up the night sky across the globe. Musk's ideas follow what the scientists earlier predicted about the star's eventual supernova. Betelgeuse, one of the brightest stars visible from Earth, has long fascinated astronomers. Recent observations have revealed unusual behaviors, such as dimming and brightening, indicating that the star is undergoing complex changes. But even more astonishing is another discovery scientists have just made about Betelgeuse. We know you're curious about this discovery. Stay tuned, because we've got all the details coming up. Betelgeuse has been known in the night sky for a very long time, but scientists only began studying it seriously in the 1800s. When tools like spectroscopes were invented, astronomers could study stars by looking at the light they give off. In 1836, John Herschel was one of the first people to notice that Betelgeuse changed in brightness. This meant it was a variable star. Later, in the early 1900s, scientists studied its light more closely and learned that it was a red star, cooler than the sun. That's when Betelgeuse became more than just a bright spot in Orion. It became an important object for scientists to study and learn about how big stars live and die. Because of that, Betelgeuse was given a specific label based on its light and size. It is called a red supergiant and falls under the spectral M-type supergiant. That means the star is cool in temperature, and the rest shows it is very large and bright and near the end of its life. These kinds of stars are rare and don't last long. As astronomers kept watching Betelgeuse, they found that it was not only big and cool, but also unstable. That made it very interesting to study because it could help explain what happens to stars much bigger than the sun near the end of their lives. At the same time, other red supergiants were also being studied. Andreas is one example. It's in the same group as Betelgeuse, but is slightly cooler. VY Canis Majoris is even larger and loses mass more quickly. These stars are helpful for comparison. What makes Betelgeuse stand out is that it is much closer to Earth than the others, about 700 light-years away. Because of this, scientists can see more details on its surface and study its changes more closely. This helps them understand not just Betelgeuse, but also other stars like it. Then comes the question of how Betelgeuse was formed. Like all stars, it came from a cloud of gas and dust. But it was born with a lot more mass than stars like the Sun, maybe 11 to 20 times more. That made it live faster. Massive stars like Betelgeuse burn their fuel quickly and go through their life stages in just a few million years. Beyond all this, there's something even more fascinating about Betelgeuse, an unusual trait that has truly captured the attention of scientists. The Sun, by contrast, will take billions of years to reach the same stages. Scientists believe Betelgeuse is only about 8 to 10 million years old, but because it is so big, it has already gone through most of its life. As it aged, Betelgeuse used up the hydrogen in its core and began fusing helium into carbon. This is normal for stars in this stage. After helium, the star will move on to fusing heavier elements like oxygen, silicon, and then iron. But once it reaches iron, it can't produce energy from fusion anymore. When that happens, the star becomes unstable and starts to collapse. Scientists think Betelgeuse is now in the helium fusion stage, but could move on to the later stages sometime soon, though soon in space could still mean thousands of years. Because of how big it is, Betelgeuse changes faster than smaller stars. Its size and mass mean that it burns fuel quickly, changes shape, and becomes unstable more easily. These changes happen on a scale that we can sometimes see in our own lifetimes, which is rare in space. Most stars change slowly, but Betelgeuse changes in ways that scientists can watch year by year. That's one of the main reasons why people are paying close attention to it. It lets us see how a big star behaves as it nears the end of its life. In fact, Betelgeuse is a type of star called a variable star. Its brightness doesn't stay the same. Scientists have found two main patterns in how its light changes, one that lasts about 400 days and another that takes around 5.6 years. These changes happen because the star is constantly expanding and shrinking a little. This causes it to get brighter or dimmer over time. These pulses are signs of what is going on inside the star and give clues about its health and future. What also makes Betelgeuse interesting is what's happening on its surface. The photosphere, or outer layer, is not smooth. When scientists looked closely using special telescopes, they saw big areas moving and changing. The surface looks bumpy and rough, with hot material rising and falling. These changes can cause the star to look dimmer or brighter, and they also tell us that there's a lot of activity going on inside. These kinds of details help scientists better understand what's happening under the surface of the star. This brings us to what happened in 2019 and 2020. That's when Betelgeuse suddenly became much dimmer than usual. Some people thought it was about to explode, but scientists later found that it had gone through something called a surface mass ejection. This means a large part of its outer layer was thrown off into space. The material cooled and formed dust, which blocked some of the star's light and made it look dim from Earth. This kind of event is similar to what the sun does on a smaller scale, but this one was much bigger. After this event, scientists noticed another change. One of Betelgeuse's regular light changes, the one that lasted about 400 days, became shorter, dropping to about 200 days. That means something inside the star had changed. It could be that some of the material that was thrown out changed the way the star moves and pulses. Scientists are still watching to see if these changes continue. Studying these shifts can help them understand what happens to stars just before they explode. One day, Betelgeuse will explode as a supernova. This will happen when it runs out of fuel and its core collapses. Scientists think this could happen within the next 10,000 to 100,000 years. When it does, the explosion will be very bright, bright enough to be seen during the day from Earth. But even though it will look bright, it won't hurt us because Betelgeuse is far away. It will just be a big light show in the sky. After the explosion, the star will leave behind a small, very dense object. If the remaining core is not too heavy, it will become a neutron star. But if the core is still very massive, it may collapse further and become a black hole. Scientists aren't sure yet which one Betelgeuse will become. They'll only know for sure after it explodes. Watching the supernova will help them figure it out. Until then, Betelgeuse keeps losing mass in a slower way through something called stellar winds. These are streams of particles that blow away from the star over time. Because of these winds, Betelgeuse has already lost a lot of its original mass. But even so, years of studying Betelgeuse have led scientists to uncover something remarkable about the star. It's a discovery that adds a new layer to the star's story. Stay tuned to find out what Betelgeuse looks like, what scientists found in Betelgeuse's past. Betelgeuse is a red supergiant, and as such, its stellar radius is one of its most impressive features. Its radius is estimated to be between 700 and 1,000 times larger than that of the Sun. If placed at the center of our solar system, this enormous star would stretch all the way out past Mercury, reaching as far as Jupiter. The sheer size of a red supergiant shows just how large stars can become. While it may appear massive, this size also affects its brightness. A larger surface area means the star emits more light, but because of its cooler temperature, this light is less intense compared to that of smaller, hotter stars. This immense radius and the amount of space it covers are both a sign of the red supergiant's advanced stage in its life cycle. Having expanded far beyond its original size, it is nearing the end of its life. The temperature of a red supergiant is another key characteristic. With an average surface temperature of around 3,500 kelvins, it is significantly cooler than the Sun, which has a surface temperature of 5,778 kelvins. This lower temperature results in a redder appearance, giving the star its name. The cooler temperature is an important feature in understanding the star's evolution. It tells us that the red supergiant is no longer in the phase of nuclear fusion that powers smaller, hotter stars like the Sun. Instead, it is in a later stage of its life, one where it has expanded and cooled. While its size grows, its temperature drops, changing the way it interacts with its surroundings. This shift in temperature also influences the type of radiation the star emits, making it less energetic than hotter stars, which is another sign of the red supergiant's aging process. In terms of mass, red supergiants are much heavier than the Sun. Their mass is estimated to range between 11 and 20 times that of our star. However, the mass of a red supergiant can be difficult to measure precisely. Over time, these stars lose mass through powerful stellar winds that blow off large amounts of material. Because of this constant loss of mass, it's challenging to know their exact current mass. Still, it's clear that they are much more massive than the Sun. This mass plays a big role in how the star burns its fuel and evolves. More massive stars burn their fuel faster, which is why red supergiants go through their life cycle more quickly than smaller stars. Their larger mass ensures that they are short-lived in astronomical terms, eventually leading to their dramatic end as a supernova. But that's not all. One interesting feature of red supergiants is their rotation rate. These stars spin much faster than you might expect. Despite their large size, the rotation period of a red supergiant is estimated to be under 30 years. This is quite fast, especially when compared to other stars of similar size. Most red supergiants rotate slowly because their outer layers are diffuse and spread out, making the rotation less rapid. However, this faster spin could be due to several factors. It might be a result of the star's mass or a leftover effect from earlier in its life. Regardless, this rapid rotation affects the star's magnetic field and how it interacts with the material around it. A faster rotation could also influence the star's stellar winds, leading to different patterns of mass loss. Betelgeuse has even more fascinating features beyond these. Most of the time, it is the 10th brightest star we can see from Earth, but its brightness changes from time to time. In some recent years, Betelgeuse became even brighter than usual and moved up to become the 7th brightest star for a while. These changes are not random, they show us that something is happening inside the star. Because of that, Betelgeuse is one of the rare stars that people can study just by looking with their eyes. Many stars are too far or too faint to notice small changes, but Betelgeuse is close enough and bright enough that its changes can be seen without a telescope. Over the years, both scientists have paid attention to how it brightens and dims. This long record of watching has helped us learn more about how stars behave over time. Because the dimming got so much attention, big telescopes were used to study the star more closely. The Very Large Telescope in Chile and the Hubble Space Telescope took pictures of Betelgeuse's surface. That was a big deal because most stars are so far away that even powerful telescopes can't see more than a point of light. But Betelgeuse is close and large enough that we can actually see some details on its surface. The pictures showed that the star's surface is not smooth. Instead, it has large dark spots and bright areas, which helps scientists understand how the star is losing mass over time. While scientists kept watching the star, they also looked at its light curve. That's a graph that shows how the star's brightness changes over time. Because of all these studies, Betelgeuse has become the main example used in models of red supergiant stars. When scientists build computer models to test ideas about how big stars live and die, they often use Betelgeuse as their base. Its data helps guide our speculation about how other stars like it will behave. Over time, Betelgeuse has become more than just a bright star. It has become a model that helps explain how stars end their lives. But beyond what scientists have seen, Betelgeuse also has a place in stories and traditions from around the world. For many cultures, it's more than just a bright star. It's part of legends and beliefs passed down for generations. So what do these stories say? Let's take a short look at the cultural and mythological meanings behind Betelgeuse. Stay tuned. The controversial myth about Betelgeuse. The name Betelgeuse has a long and mixed history. It likely came from the Arabic words Yad al-Jawza, which means the hand of Orionor, armpit of the central one. In Arabic sky maps, al-Jawza was the name for a figure in the middle of the sky, close to what we now call Orion. Later, when European astronomers copied these names, they made a mistake. The letter Iwas read as a B, which changed the word into something like Betelgeuse. Over time, this wrong version became the name we use today. In the same way, people from different places told different stories about this star. In Greek and Roman myths, Betelgeuse was seen as part of Orion, the strong hunter in the sky. In India, it was part of a group of stars linked to the god Rudra, who brings storms and changes. In Japan, some stories said it was where the spirits of ancestors watched over people. Other native stories said it was part of a creature or a hunter. These stories showed how people gave meaning to stars based on their own beliefs and fears. Because it was easy to see, Betelgeuse also helped people track time. In many cultures, the rising or setting of the star marked the start of a new season. For Native American groups, it could mean the coming of winter. For the Inuit in the far north, it helped them know when to prepare for the coldest months. These patterns were not just stories. They helped people plan farming, hunting, and moving from place to place. The star became a kind of calendar. With that, Betelgeuse also became part of special events. In some island cultures, people watched it before they sailed, believing it would help guide them safely. In parts of Africa, its return to the night sky was a signal to begin planting crops. People saw its regular path as a sign that it was time to act. They included it in songs, dances, and prayers that connected nature to their daily lives. Even when the star was not visible, its memory helped guide choices. In recent times, Betelgeuse has shown up in popular stories and movies. The 1988 movie Betelgeuse got its name from the star, although it changed the spelling and meaning. In books like The Hitchhiker's Guide to the Galaxy, a character comes from a planet near Betelgeuse. In the TV show Doctor Who, the star is also mentioned. Even if the stories are made up, they keep the star in people's minds and show how old sky names still shape new tales. Because it is so bright, Betelgeuse was also used in travel. Before there were compasses or maps, people looked at stars to find their way. Sailors in the north and south could both see Betelgeuse because of where it sits in the sky. This made it useful for long sea trips. Arab traders, Pacific Islanders, and others used it as a guide. They passed down knowledge about the stars by memory, teaching children how to follow paths in the sky. At the same time, Betelgeuse is important in astrology, especially in India. It belongs to a group of stars called Ardra. This group is linked to Rudra, a god known for storms and change. People born under this star are said to face strong emotions and big life shifts. The star is seen not just as a light in the sky, but as something that shapes people's nature and future. For some, this belief still guides how they see themselves and their path. Artists and writers have also shown Betelgeuse in their work. In the past, people drew detailed star maps that included it. In Europe and the Islamic world, painters and scientists showed it as part of Orion. Its red color made it stand out. Poets used it to show strong feelings, while painters placed it in the sky of landscapes. Over time, it became a symbol of something powerful, constant, and a little strange. In 2019, Betelgeuse started to act strangely. As this happened, some indigenous groups began to reconnect with old sky stories. In Australia, for example, Aboriginal stories link Betelgeuse to a hunter's fire or body. These stories are not just myths, they are part of land and life. People are now trying to save and share this knowledge. They see the star not just as a science subject, but as part of who they are. Betelgeuse helps bring back old names, languages, and beliefs. In some places, Betelgeuse is still part of local customs. In parts of the Pacific and Asia, it's used to mark farming times or community events. The practice may not be common anymore, but some people still remember it. Teachers and elders pass on the knowledge in schools and cultural centers. The star helps young people learn about their own history and how their ancestors watched the sky. Even in cities where lights hide most stars, Betelgeuse is often still visible. People who don't know its name can still see its red light. They might not know the science or the myths, but they notice it. But then, there's one event the whole world has been waiting for: the explosion of Betelgeuse. It's expected to be unlike anything we've seen before, a cosmic event so powerful it could light up the sky for weeks. But what could this mean for us? Will it affect people on Earth? Could it even change conditions on our planet? The answers might surprise you. What will happen if Betelgeuse explodes? The explosion of Betelgeuse, a massive star near the end of its life, will be one of the most amazing events in our galaxy. When it happens, the results will be far-reaching, changing the space around it in ways that could last millions of years. From creating new stars to filling space with heavy elements, the explosion will start a series of changes that will continue to shape the galaxy. According to scientists, when Betelgeuse explodes, one of the first effects will be the birth of new stars. A supernova, like Betelgeuse's expected explosion, sends shock waves through the gas and dust between stars. These shock waves push clouds of gas together, causing them to collapse. As the gas gathers, it heats up and can eventually form new stars. This process, known as triggered star formation, has been seen in other parts of space. Betelgeuse's explosion will likely cause new stars to form around it, just as past supernovae have triggered star formation in other regions. Along with forming new stars, Betelgeuse's explosion will also spread heavy elements like iron, gold, and uranium throughout space. These elements are made in the cores of large stars. When the star dies in a supernova, these elements are thrown into space. This is important because these heavy elements are the building blocks for planets and other objects in space. Without supernovae like Betelgeuse's, these elements would not be available to form new stars, planets, or life. The explosion will fill the surrounding space with the materials needed for the next generation of stars and planets. Betelgeuse's explosion will also create a nebula, a large cloud of gas and dust. The explosion's remnants will form this nebula, which will become a cosmic laboratory for scientists. Nebulae are where new stars are born, and studying them helps us understand how stars and planets form. Scientists will learn more about how the death of a star can lead to the creation of new stars, planets, and solar systems. The shock waves from Betelgeuse's explosion will move through space, disturbing the nearby regions. The gas and dust between stars will be affected by the explosion. This disturbance can change the nearby gas clouds, either causing new stars to form or delaying the process. In some areas, the shock waves will push the gas clouds together enough to make new stars. In other places, the shock waves may prevent the gas clouds from collapsing, slowing down star formation. The explosion's impact on the interstellar medium will be wide-reaching, and it may affect how nearby stars form for years or even millions of years. After Betelgeuse's explosion, astronomers will collect a vast amount of data to study the event. Observatories around the world will examine the light from the explosion, along with its spectrum, to understand what is happening. The data from Betelgeuse's explosion will help scientists improve their models of how stars die and how elements are spread throughout space. Such data will include light curves, which track how bright the explosion is over time, and spectroscopic data, which shows the composition of the light and, by extension, the elements created in the explosion. This will provide valuable information for improving our understanding of supernova and stellar death. However, there is another side to that. The large amount of data from an event like Betelgeuse's explosion will present major challenges. The amount of information from observatories around the world will be huge. Scientists will need new tools and techniques to handle and analyze the data. With different telescopes and instruments tracking the explosion in various types of light, from visible to infrared to radio waves, the data will be complex. To manage this, astronomers will need to develop new methods of analysis using advanced algorithms and computer models. The explosion of Betelgeuse will push the limits of current research tools and show the need for more innovation in data processing and analysis in astronomy. The massive amount of data won't just challenge scientists. More so, according to scientists, the explosion of Betelgeuse will likely begin quietly, possibly not with loud sound, but with something invisible. Deep under the Earth, in places like Japan and Antarctica, special detectors will notice something strange, a sudden burst of tiny particles called neutrinos. These particles will come from Betelgeuse, a giant star far away. They travel slower than light, so they will arrive long after the explosion. Some of them may hit Earth, but there is no need to worry. Earth's air and magnetic field protect us. Not only that, people everywhere will see a new, very bright star in the night sky. It will be brighter than the full moon, and might even be visible during the day. This bright light will stay for weeks or months. It will change how the sky looks, especially in places where Betelgeuse is easy to see. Even though the light will be bright and the event big, there will be no danger to Earth. Betelgeuse is far away, over 600 light-years from us. That distance is enough to keep us safe. Harmful rays from the explosion, like gamma rays or X-rays, will lose their strength long before they reach us. However, it will signal the knowledge that other stars nearby could explode much closer to home. For example, stars within 100 light-years of Earth could have a huge impact on our planet. A nearby supernova could release dangerous radiation, damaging Earth's atmosphere and disrupting satellite communications. One nearby star system, located about 150 light-years away, is considered a potential supernova. While it's not expected to explode anytime soon, its eventual explosion could pose a threat. Betelgeuse's explosion will draw attention to these risks and encourage scientists to monitor nearby stars closely. One of the most serious concerns of a nearby supernova is the risk of mass extinction. Studies have shown that a supernova within 100 light-years could harm Earth's ecosystems. The radiation from such an event could destroy the ozone layer, and allow harmful ultraviolet rays from the sun to reach the Earth. Some researchers believe that past mass extinctions, like the Ordovician-Silurian event about 450 million years ago, may have been triggered by a nearby supernova. While Betelgeuse's distance reduces the threat, it is still a warning about the potential dangers of cosmic events. Beyond the scientific interest, it holds lessons for how we understand the universe and our place in it. One of the key takeaways from the expected explosion of Betelgeuse is the realization that our models for stars are not perfect. Scientists have long thought that stars like Betelgeuse follow predictable life cycles, but the sudden dimming of Betelgeuse in 2019 took many astronomers by surprise. Although some feared the star might explode soon, further studies revealed that the dimming was caused by a large dust cloud, not the star's death. This unexpected behavior shows that our understanding of how stars evolve is still incomplete. If scientists can't predict when a star like Betelgeuse will explode, it raises questions about how reliable our models are for other stars. This uncertainty pushes astronomers to refine their methods and observe stars more closely to better understand how they die. What are your thoughts on the potential Betelgeuse supernova? Do you think the scientific predictions about its timing and impact are accurate? Share your thoughts in the comments below. Don't forget to like and subscribe to our channel. Also, click on the next video on your screen. You won't want to miss it.